thing about squares. Squares are both rectangles and rhombuses. They're special. So if this is like an RE and this is an RH and that's just an S, and I draw a pretty Venn diagram, rectangles are over here, rhombuses are over here, and squares are where they come together. So every square is both a rectangle and a rhombus, but not every rhombus or rectangle is a square. But they're all quadrilaterals. And then we have some theorems. The diagonals of a rectangle are congruent. So if I have a rectangle and I draw two diagonals, and I call it AB, CD, AC is going to be congruent to BD. And if I have a rhombus and I draw the diagonals and I call it ABCD, AC is perpendicular to BD. And then the diagonals of the rhombus bisect the angles. So if we have a rhombus up here and it has a diagonal, these are now equal. If a parallelogram has a right angle, it is a rectangle. Because parallelograms, if you think about that, I'm going to go to this picture just for a second. Remember parallelograms, the opposite sides are parallel and opposite angles are congruent? Well, if this is 90 degrees, then this has to be 90 degrees also. Well, consecutive angles are supplementary, so they add up to 180. So if this is 90, that has to be 90, and this has to be 90. So once one of them is 90, they all have to be 90 if it's a parallelogram. Does that make sense? So if it has one right angle, and you know it's parallelogram, it's a rectangle, period. And if it has two adjacent sides that are congruent, it's a rhombus, because if I have some parallelogram like this, and this side is congruent to that side, well, these sides are congruent, and those sides are congruent, so that makes it a rhombus. So once you have these two sides congruent, it just snowballs. So if we call this ABCD, we have four right angles. If we give our diagonals, AC will be congruent to BD, and opposite sides are parallel. Every rhombus is a parallelogram with four congruent sides, so I have my four congruent sides. I'm going to do this better. My diagonals are perpendicular to each other. And it will cut my angles, it bisects my angles. These will be equal, and then these will be equal. And then every square is both, so squares have all of these characteristics. That's what I was looking for. So if I if I do my diagonals, they're going to be perpendicular. They're going to cut each of these angles in half, so they're all going to be 45 degrees, because 90 degrees in half is 45 degrees. And then if I name this ABCD, I'm still going to get AC is congruent to BD. So I have all of the traits of both a rectangle and a rhombus, if you're a square. All right, the way that they want you to do this is to use the distance formula and slope, because they're parallel, and we can just count spaces because these are both even, right? They're flat, so they're both at 7. Well, if these are both at 7, what are these both going to be at? So that's going to be 3. Well, you were correct. Your shot in the dark was perfect. So this is going to be 3 because these lines are parallel and they have no slope. The slope is 0. Slope is 0, so it's just going to be moving straight across that flat line. So the y value will be the same. Now, to get from a 1 to a 6, how many spaces did I walk? 5. So I'm going to, if I went 5 spaces here, I'm also going to go 5 spaces here. So to get from -2, and then I go 5 spaces, I'm going to do -2 plus 5. So I have 3. Make sense? Okay, now I want to show you if hypothetically these had not been flat. Okay, so I'm going to take this same picture here. Oh, I'm not. Darn it. Maybe. Nope, it's not going to let me. Okay, I'm going to quickly sketch out this same picture here.
Isn't that a weird form of situation where things like the equations break down to in a 3-dimensional space?
No, we're still in 2-dimensional space.
Okay.
Actually, you know what? Let me do it on graph paper because it'll make more sense that way. I'm going to insert some graph paper. I'm going to stick it down here in the corner, and I'm going to draw some axes. Because it doesn't always work out that the rhombuses are perfectly flat like this. So I'm going to take the same points, but we're just going to pretend it wasn't flat. And we couldn't just count 5 over. Okay, and I knew that, well, I guess once I put it on a graph, it's kind of silly. Okay, well, I need to find D, right? So I've plotted A, B, and C. They didn't give us D. I want to find D. I'm going up and over. Do you see that? So I'm going 1, 2, 3, 4 up and 3 over. So I want to do like the same kind of pattern to find D, except I'm going to go backwards. And I'm going to go 3. So 1, 2, 3, and 4. And that gives me the location of D, for D to be a rhombus. Yep. So you want to just find the same, you want to move the same number of spaces. And then you've got your parallelogram and your rhombus. Does that make sense? Yeah, okay. Angle EDC is 37. That's really way too small for you guys to even begin to see it. There we go, 37. I want to find EDA. Well, it's a rectangle, so what is this whole angle? $90, right? So angle D is 90 because it's rectangle. So EDC is this little piece. So I'm going to do 90 minus 37. And I'm going to get 53 degrees. Okay, HIJK is a rhombus, which means that all these are going to be the same length. Not that we need that, but the measure of LKJ, so LKJ is 29. And what do we know about diagonals of a rhombus? They bisect the angles. So these angles are going to all be the same. And I'm looking for HIL. So I'm looking for this angle right here. here, come back to this picture. Do you see when I bisect the angles of a rhombus, I get 4 congruent angles, and I get 4 congruent angles here. The diagonals bisect the angles. So all 4 of these angles will be the same. So if this one's 29, they're all 29. And then depending on what, I don't know what H and J were, but when they're cut in half, all 4 of these would also be the same. So with dots to make it easier, all 4 of those are the same. All 4 of these are the same on a rhombus. MNOP is a square. QO is 17. Well, squares are also rhombuses, and diagonals on rhombuses are perpendicular bisectors of each other. And bisect means to cut in half. So if this is 17, what's this? So what's the whole thing?
34.
So 34. Yeah. Yeah, since each half is 17, the whole thing is 34.
The halves are, not the angles.
Yeah, no, the halves of the lines are perpendicular bisectors of each other. So in this would be congruent to this, and this one would be congruent to that one. Well, and since it's a square, they'd actually all be congruent to each other. But if it was just a regular rhombus, it would be okay. Now I want to find the coordinates of point D. So, all right. So what I'm going to do, I'm going to plot the 4 points that they've given me. So A is -9, -5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. That's A. Okay. And B is -9, 1. So that's B. C is -4, 1. And I need to find D. Well, it's a rectangle, so we're going to have 90-degree angles, right? So this is one side. It's going to be the same length here. So if I'm 6 spaces here, I'm going to be 6 spaces here. So D is going to go right here. Does that make sense? So then I just need to find those coordinates. It's -4, -5. We have trapezoids. Trapezoids look like a triangle that you chop the top off of. The bases are the parallel sides. The legs are the not parallel sides. You have 2 pair of base angles. You have the top bases angles and then the bottom bases angles. So 2 pair of base angles. And I'm drawing these really thick and funky because they're not necessarily congruent. I wasn't trying to show them as being congruent. I was just saying that these blue ones are a pair and the red ones are a pair. Okay. So I'll just put not necessarily congruent. Oh, I'm still in the wrong. So not necessarily congruent. Sometimes they are, but they're not always. An isosceles trapezoid has congruent legs. So congruent legs. And the median is if you go halfway up each of the legs and draw a line between it, you have a median. Yeah, but it's for other stuff. But you can go over here if you want to. But see, I'm going to draw the theorem stuff for that. So you don't have to draw these if you don't want to. Okay. One of the theorems is if you have an isosceles trapezoid. So isosceles trapezoid, that means that each pair of base angles are congruent. So these are congruent to each other, and these are congruent to each other. So this is the theorem 54. Okay. In addition, and I'm going to draw another isosceles trapezoid so we can show this. If I have an isosceles trapezoid, which that is not, nor is that. That's not even a trapezoid. Wow. Close enough. If I have an isosceles trapezoid and I come in with diagonals, the diagonals are also going to be congruent to each other. So if this is ABCD, AC will be congruent to BD. And that's theorem 55. Okay, and the median of the trapezoid. So this is base 1, this is base 2. The median, I'm going to call M, is equal to base 1 plus base 2 divided by 2. So it's half of the length of the two bases added together. And that's theorem 56. LM is 8. And PQ is a median. So what is PM? Yeah, PM is 4. Perfect. So if it has a median, that means these are the same length. So you just divide by 2. So 34 divided by 2. ADC, okay, now it told me it's isosceles, right? So that means these angles are the same and these angles are the same. Okay, if ADC, so that's angle D, is 59, BCD is also 59 because they're the same. Okay, AB is 16 and DC is 24. And we have a formula that says the median is equal to base 1 plus base 2 divided by 2. So 16 plus 24 divided by 2. So yeah, 40 divided by 2 is 20. And if DAB is 109, DEF. We haven't talked about that. These are parallel lines, right? And this is a transversal. If I were to extend these out, this angle and this angle are the same because of alternate interior angles. So these two angles are going to add up to what? 180. So I'm going to do 180 minus 109, so 71 degrees. The correct angle, DEF is this red angle here, DAB is this red angle here. So they're the same, so that's 109. Now if I was asked to find the angle that I found to begin with, which was AEF, that's the green angle, that's 180 minus 109. So the green angles are all going to be 71. Does that make sense? So I had looked at I was doing the wrong angle.